in this video, we're going to analyze a sine or cosine function. In our case, we're going to be looking at a cosine function and a sine function, so we're going to do both. So we're going to look at the key features of the graph of a cosine function for this first example. All right, so I have y equals 4 cosine of 3x plus 1. Move that back up a little bit. So looking at the pieces and the parts for these, let me pick a couple of colors that will show up pretty well with this. We're going to look at my amplitude. We're going to look at my period. And we are going to look at my midline. All right, so let's start with amplitude. Amplitude is the absolute value of the coefficient multiplied to your periodic function. So my amplitude is going to equal the absolute value of 4, which is just going to be 4. My period is going to equal 2 pi over the coefficient of x, which is going to be 3. So it's 2 pi over 3. And my midline, my DLI, let me go back on that. My DLINE is going to be my vertical shift, which is going to be 1. Okay, in this graph, there's no phase shift. We're not adding anything to x. It has not been shifted horizontally. So in general, this is just going to be an amplitude, period, and midline transformation. But to go along with this, to do the general formula or the general form of the transformation of a cosine function, you would see something like g of x equals a for amplitude, cosine b, it's just b, I guess I could use p, but b of x minus h, and this is your phase shift, plus k. And in our case, h is 0. All right, so this is amplitude. I don't know why I don't extend those L's. Amplitude. This is period. Remember, period is going to be 2 pi over b. This right here is your phase shift. Just to make sure I put the top part of that on the h. And this k is going to be your midline. All right, so that is the general form for our function. What does this look like graphically? Well, let me get my handy dandy ruler, draw this out. There's my x. Flip that 90 degrees. I know I keep saying I gotta find a way to write this, and do I ever try? No. We don't have a phase shift, so I'm going to start here on this end. We do have an amplitude, so I'm going to go a little bit higher. I always never draw these high enough. And we go up 1, so we do have to go up to 5 here. I'll do -4 here. What I'm going to do is I'm going to start with my original cosine. So 1, 2, 3, 4, -1, 2, 3. I guess I'll move the -4 up a little bit. To here. All right, 1, 2, 3, -4. Okay. So cosine starts at 1. We do have 2 pi over 3. That's going to be fun to graph. This is 2 pi. Half of 2 pi is pi. Half of that is pi over 2. Half of that is 3 pi over 2. When I graph these, I always divide it into half because if you think of the circle, we have the 4 quadrants. And with each of those quadrants, you have, when you start out with a cosine, you start out at 1, then you go to 0. When you're at the pi over 2 or the 90 degrees, then you go to pi when you're at 180 degrees or pi, or sorry, you go to 1 when you're at -1 when you're at pi or 100 or 180 degrees, and then at 270 degrees or 3 pi over 2 you're back at 0. So and then 2 pi you're back at 1. So that's why I divided into 4 quarters. These are the 4 quarters of that unit circle that I divide this into, the 4 main parts of that unit circle, which then allows me to draw these points and try to draw that curve as best I can. So now we're looking at a phase shift of 2 pi over 3. So thinking of pi, pi is actually going to also be 3 pi over 3. And so 2 pi over 3 would be somewhere around here. Pi over 3 would be somewhere around here. So 1, 2, 3. So I'm dividing that into 3 pieces. And so this whole structure, this whole thing right here needs to fit into this little area here. So what I'm going to do is I'm going to pick a different color. I know that I'm going to end at 1 here. I start at 1 here. I got to try to divide this. I lied. I went too far. This one right here. 1. Divide these 2 in half. And I'm just eyeballing it. This is just a general sketch. This is not exact. Divide these 2 by half, which would be roughly there. These 2 by half, which would be roughly there. And again, now we have that period of 2 pi over 3. Now, I'm going to multiply by 4. Notice how I do the period first before I do the multiplication, because I want to make sure that horizontally I'm where I need to be before I do anything vertically. I personally choose to do horizontals before verticals. You don't have to go in that order. For me personally, I find that doing the horizontals first, because again, you're making changes to just x, helps you with changing that output, that y, since all the changes to x will then affect y, as opposed to y affecting x. Y is your dependent, x is your independent, so I try to do the independent first. Alright, so the next thing I'm going to do now then is my amplitude. I'm going to multiply each of these points by 4. So 1 times 4 is 4. That's too close to that pink color, so let me choose this green color. 4. That's still not green. 4. 0 times 4 is 0. -1 times 4 is going to be -4. 0 times 4 is 0. And 1 times 4 is 4. So we've now stretched this cosine function to kind of a max there. And then the last thing we need to do is this midline. We're shifting all these points up basically just by 1. So this moves up by 1. This guy moves up by 1. This point moves up to -3. This point moves up to 1. And this point moves up to 5. So this hot pink mess of a graph is our final function. This actually curves. I'm not doing a very good job in showing that curve. But ultimately, this is what our function would look like. And then again, this period is 2 pi over 3. There's a circle. 2 pi over 3. Alright, so that's the cosine function. Nice, beautiful cosine function. But let's look at a sine function now. So let's look at the sine function y equals -3 x plus pi over 2 minus 2. Okay, so now we have a little bit of a curveball. We have this -3. The -3 is going to flip the graph over the x-axis, and then we have the amplitude of 3. So the way I treat this is I'm still going to say the amplitude is 3 is equal to the absolute value of -3, which is 3. We don't have a period, but we do have a phase shift. Of left by pi over 2. And then our midline is down 2. Our vertical translation. Okay, so now what we're going to look at, and luckily I have a graph from a previous example. What we're going to look at is, again, I don't have to do anything with my period, but I do have to move this back. I do have to move this back by 2. Oh, not wanting to do that. So I'm going to move this guy over a little bit. Get my handy dandy ruler here. Doo-ba-doo. Seen to you guys while I tried to bring this up, and I know that's not exactly at 0, so we'll move it down to 0 degrees there. Try to match that pink. I never can. And we're going to move this back by pi over 2. So this point moves back by pi over 2. And then we do that for each point. So this point moves back by pi over 2. This point moves back by pi over 2. This point moves back by pi over 2. And this point moves back by pi over 2. So now we have this function here. Okay, our phase shift is taken care of. I'm going to do the amplitude next. I think I'm going to use a rose pink color for amplitude. And again, we're just going to multiply each one of these points by, and I'm actually going to multiply it by -3, because then that will automatically build that reflection across the x-axis into my graph. So pi over 2 as 0 here, 0 times -3 is still 0. 1 times -3 would be -3. And see, now we've just built that reflection into our graph. 0 times -3 is 0. -1 times -3 is going to be 3. 0 times -3 is 0. Alright, I'm going the wrong direction after I told you we're doing a reflection, and then what do? I start going up instead of down. And there we go. So even though the amplitude is 3, using the -3 helps us with that reflection. And I know that one's a little bit off. I'm sorry about that. Okay, and now the last one is we're going down -2. So my midline, which means these 3 points, this middle of the graph, because this is my amplitude, so this is the middle. If I do max minus min in the middle divided by 2, or max plus min divided by 2 is going to be my middle. So that's my midline. We're going to move that down by 2. Basically, we're just going to subtract 2 from each one of these points. So 0 minus 2 is -2. -3 minus 2 is -5, and I'm just going to put -5 here because I did not extend that to where I needed it to be. This is going to be -2. This is going to be 1, and this is going to be -2. Okay. So then we have a graph where the peak is at 1, the valley is at -5, The midline is at -2. Yeah, there we go. There's your transformation. All right, so yeah. So notice that the combined efforts on the reflection of the phase shift produce a graph that could be interpreted as a sine graph without a reflection and with a phase shift of pi/2 units right. So if I look here, it looks like a sine graph. Just moved over pi/2. So the sine graph starts here, goes up, down, and then up. So it could look like a sine graph moved over this way, but it's a reflected sine graph at -3. So it could look, because this is a periodic function, your reflections can actually at some point look like a non-reflected graph. Alright guys, so this is analyzing a sine or cosine function, looking at the transformations, looking at the different pieces. If you have any questions, always feel free to contact me and I'll catch you in the next video.